Alright, our last target for this unit is converting equations into slope-intercept form. You're going to follow the steps of this activity to learn how to convert and why it is useful. So let's take a look at some of the stuff we've done already and then put it all together in one lesson. We started off the unit with these types of equations, and I asked you to identify the x and y intercepts of these equations. So to find the x and y intercepts, I said let x equals 0 and solve for y, and let y equals 0 and solve for x. So remember, if we were doing this for the first one, I would do -4 parentheses 0 plus 2y equals 12, because I'm letting 0 take the place of the x. Anything times 0 is 0, so this becomes 0 plus 2y equals 12. If you add anything with 0, it's the same value. And then dividing by 2, I get y equals 6. Now, let me try plugging in 0 for y and see what I get out for x. So when y is 0, x is -3. Remember, one trick I used to do this was I would cover up the value of the number I'm plugging in 0 for. So for example, if I plugged in 0 for y, I can cover up the y's. And then I'm just solving -4x equals 12, and then divide by -4, x equals 3. On the flip side, I can cover up the x. And when I do solve this one, now I've got 12 divided by 2, which is 6. So we started off the unit with these type of problems. These gave me my x and y intercepts. So I could plug in this answer onto my graph. 0, 6 is up here, and -3, 0 is right here. From this, we can identify the y-intercept on our graph. So the y-intercept is equal to 6, because it's at 0, 6. And the slope, let's take a look. From this point to this point, remember we always go from the left to the right. It's up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So it's 6 divided by 3, which is 2. So to write this in the new form that we learned as well, this would be y equals 2x plus 6, using the slope and the y-intercept for slope-intercept form. So I started off with this equation, and it turned into this equation. So let's try another example. Same idea. Here I have an equation in standard form, and we're going to write it into slope-intercept form. So I'm going to find my intercepts. I'm going to plug in 0 for x, and I'm going to plug in 0 for y separately, and then see what comes out. So 2 times 0 plus 3y equals 6. 2 and 0 is 0, plus 3y equals 6. Anything plus 0 is itself. Y equals 2. Now I'm going to plug in 0 for y and see what comes out for x. I got x equals 3. So using that information, I found my x-intercept and my y-intercept. I'm going to plug or graph those points onto the graph to the right. So I've got 0, 2, which is on the y-axis, that's my y-intercept, and 3, 0 is my x-intercept. Remember, just by looking at the graph, you can tell me some things, and right now I can see that this is going to be a negative slope because the line is going down. So I know my y-intercept is 2, because that's where it's crossing at the y-axis. And now let's figure out the slope. Remember, you always go from left to right, so I'm starting at the point that's furthest on the left and moving to the point that's on the right. I'm going down 2 spaces and over 3 spaces. So my slope is negative 2/3. So writing that in the slope-intercept form, I have y equals negative 2/3 x plus 2. Alright, so let's ask this question on the back of the next sheet. Why does rewriting the slope-intercept form help us? So why does it help to go from this equation into the equation we discovered, that one? Why is that beneficial? And the main reason we like having that is that it's easier to graph in slope-intercept form. If you have the slope and the y-intercept, you're going to be able to plot the point for the y-intercept and use the slope to get another point and graph. It's a little bit harder to do that in the standard equation when you see it listed as in a standard equation. So what we're going to work on is taking these equations in standard form and turning them into slope-intercept form, just so it's easier to identify the slope and the y-intercept. So for this part, we're going to work on rewriting the equations if we need to. So in example 1, it says identify the slope and the y-intercept of the given equation and graph the equation. There's a little note. In this problem, it's easy to identify the slope and the y-intercept because the equation is already in y equals mx plus b form. We're used to this. So the slope in this one is negative 2. That's my slope. You do not write the x when you're writing the slope, you just write the number. And the y-intercept is negative 6. So that means on my graph, I put a dot on the y-axis for negative 6. So that means that's where it's hitting the y-axis. And my slope is saying negative 2. Remember, negative 2 can be written as negative 2 over 1. So it's always rise over run when you're doing slope. And if it's negative, that means you're going down first. So I'm going to start at the 6, negative, and go down 2 and over 1. I can go down 2 and 1 again. That's the whole point of the slope, is that you can keep using your slope to find other points. And here, we've got our nice line. Okay, so let's look at the next example. Identify the y-intercept of and slope of the following equation, then graph it. Take a look at this one. This one's not in y equals. In order to use the slope-intercept, we have to have it in y equals. So I'm going to just rearrange this equation to be in y equals. And the way to do that is I want to get the y by itself. So how do I undo subtracting 4? The opposite of subtracting 4 is adding 4. So I'm going to add 4 to both sides. Y equals, this does not combine. These are not like terms. You can't tell me that this is 5x. That would be incorrect. You just write this as a statement of you adding two things together. You're adding x plus 4 because they're not like terms. And now this is a form that we're used to. The slope here is 1 and the y-intercept is 4. So I can graph my y-intercept at 4 and go up 1 over 1. Up 1 over 1. And there's my line. Again, to check that you're doing this right, you should see a positive slope, which I do get a positive slope with the graph that I created. Alright, let's try 2 more examples. Again, it's asking you to identify the slope and the y-intercept and then to graph the equation. But if we look at the equation, it's not written in the correct form. This says y plus 8 equals negative 5x. I want y by itself, so I'm going to undo what's happening to the y by subtracting 8. And now remember, you cannot combine here. These are not like terms. So you just write it down as a statement. Because now I have my information that I need to solve, or to answer the question. the slope is -5, and the y-intercept is -8. So I can put a dot at -8, and then use my slope. But then notice, I don't have enough spaces for 5, so I'm going to add a couple more lines here. 1, 2, 3, 4, 5, and then over 1. Because remember, you go over 1 when it's a whole number. So there's the graph of that equation. And I know it's negative, so I should be seeing my slope go down. So that's another way you can check yourself. Okay, one more example, and I'm going to have you try the rest on your own. In this equation, it's just, you don't have to graph, it's just asking you to identify the slope and the y-intercept of the following equation. But take a look, this is not in the y equals mx plus b. So we're trying to get this y by itself. That's the whole goal. So I'm going to rewrite the equation, and let's go from there. I want to move the 5x from the left-hand side of the equation to the right-hand side. Anytime you're moving something from one side to another on an equation, you have to do the opposite operation. So here, this is a positive 5x, so I'm going to subtract 5x. On this side, what's left over is a -3y. And on this side, remember, these are not like terms. I cannot combine them. But think about the form of the slope-intercept form. It says y equals mx plus b. So what I'm going to do, since x comes first in my form, I'm going to write the -5x first. And then 6 is positive, so I'm just going to write plus 6. Because that's really what this is. You're taking 6 and you're minusing 5x. I'm just rearranging the order and putting -5x first and then adding the 6. So again, I didn't combine these. I wrote the term with the x first, and then I wrote the sign positive because 6 was positive, and then the 6. And then now I want to get the y by itself. To get the y by itself, I have to divide everything by -3. So I get y equals a negative becomes a positive, 5/3. 6 divided by -3 is -2. So this equation in y-intercept form, or slope-intercept form, turns into that. So right away I can tell my slope is 5/3 and my y-intercept is -2. So you're going to work on these types of problems. You're going to identify the slope and the y-intercept of each equation. If it's not in y equals mx plus b form, you're going to have to change it. So you're going to have to rearrange the equations. So try examples 1, 2, 3, and 4, and then let's see how we do.